This is a demo of the Future Sound System's decade counter DC1 Eurorack module, as shown here. The decade counter is essentially a gate sequencer, taking a clock input to step through 10 different gate outputs sequentially. This allows for musical events to be triggered in sequence from a clock source, usually an LFO. However, as you'll see later, this module can do more than simple envelope triggering. The most basic and perhaps typical patch for the DC1 is to use the module as an event sequencer. This includes triggering envelopes, switching sources off and on, and providing a voltage source. To do this, an LFO's square output, such as the A-145 LFO, should be used as the DC1's clock input, which is here. And as you can see, once I've got that patched in, the outputs start running through sequentially. You may ask, why are there 10 outputs? Surely this isn't very musical. Well, 10 is only the maximum step length. Using the reset input, one can have as many as, 6, 7, 8, however many steps you like, up to 10. So, for example, if I want a sequence of 8 steps, I would patch in the reset input to output 9. This means as soon as output 9 becomes activated, the module resets to 1. So here we have a basic 8-step sequence which can be used to trigger an envelope or change the pitch of a VCO. So I will patch up a ADSR being triggered by step 1. So here we have step 1 of the DC1 gating the A410 ADSR, and that is controlling one of the quad VCAs, and the signal input is from the AFG. It's just a triangle out, and that's going into my mixer, which is just serving as an attenuator for now. So as you can see, as soon as the DC1 hits step 1, the envelope is triggered and we get a percussive kind of sound. So that's perhaps the most basic use of it. So this is a continuation of that basic patch, but here I've taken steps 1, 4 and 7, connected them to a multiple, and this is serving as the gate input to the ADSR. And if I begin the clocking, you'll see that there's a slightly more complex rhythm, just dotted quavers until we reach 2 beats, and then it's reset. Note that once you multiple these outputs together, the LEDs will activate for any outputs connected together. That's just the way the module is. So that again shows how you can use the DC1 as a gate sequencer, and again, if I change the outputs, I can change the sequence. Note that because the DC1 outputs gate signals, as soon as you connect 2 consecutive outputs, you won't necessarily get 2 different triggers. For example, here I've got 8 and 1 connected together, and the envelope isn't triggering twice for those 2 steps, it's only once. That's because the pulse width is effectively covering the 2 steps. You haven't gotten off within that pulse. The most extreme case of this is if I connect 1, 2 and 3 together. So you just get the 1 pulse as soon as 1 goes on. But if I alternate them, so say give, then you've got a different rhythm and it's triggering for every step. Now the other feature of the DC1 that I like to use is using it as a sub-oscillator, so effectively a divider. So you can do this by patching, say, step 3 into reset. So now it's only counting steps 1 and 2. And if I take the clock as, say, a triangle wave from the LFO, let's put the frequency up so it's audible. And then if I take output 2 or output 1, it doesn't matter which, from the DC1 into the other input of the mixer, you'll hear that we've got the octave below. Now you can do some kind of funky pitch stuff if you change this. Say if I go, that's giving me the 5th below, 5th below the octave, sorry, so effectively a compound 5th. 2 octaves, something funky. I believe that's 2 octaves and a 5th. That's something funky again. And then 3 octaves. Now, using a mixer, you can kind of generate your own waveforms. Let's take the original out, reset on 5. So now we've got 4 steps, which complements the 4 inputs of my mixer. So this will give us 4 different levels, which we can then change at will. So because I've effectively got near DC, note that there is some bleed of the clock input into the outputs. I can then change the waveform that we hear. So it's a fairly narrow kind of rectangle wave. Square wave an octave above. And you can just do some pretty cool kind of interesting square-like shapes. Again, change the reset point and change the inputs of the mixer. And you get more interesting shapes. So I can automate that with CVs if I take my outputs into a quad VCA and then get LFOs to play around with that. Whilst we're working with audio frequencies, another good patch which can create very, very interesting results is plugging an oscillator into the clock and another oscillator into the reset. Just change those over, my Doepfer VCO isn't very good. So the pulse width of the AFG is very, very low, so you're not really hearing the reset effect. This is just the clocking of the DC1 from the Doepfer VCO. Now if I increase the pulse width of the AFG, you hear that it's being reset for half of the duty cycle and then allowed to run for the other half. If I increase this frequency, you can get some interesting beating effects. And again, if I change the pulse width, that also creates some very interesting effects. So it's quite a rich sound, really. I mean, mix that in with some of the original. Quite a nice sound. We can run that through the filter. just quite a nice sound, really. The other alternative is to use, instead of the reset, is the disable input. And this gives even more of a kind of gated effect due to its job. The disable input just stops the clock from working, really. It's almost just as a gate for the DC1. So as soon as a high voltage goes into the disable input, the counting will just stop. So I can demonstrate that by putting the AFG way down low, 50% duty cycle, and as you see, it's, you know, just locking to different steps. So if we take the DC1 output again, same setup, and just reduce the pulse width of the AFG a little, increase that frequency. Here it gets quite gnarly. Increase the pulse width and the frequency again, and you get some really strange sounds. Change the pulse width of the clock VCO and get some really strange stuff. If I mix in a few of the outputs from the DC1 just to give it a broader pulse width at the output, so it just gives these kind of like weird cross-modulation sounds that you may not expect. Now, in this kind of scenario where you want a broad pulse width, you can also use the divide by 10 output, which simply is outputs 1 to 5 tied together. This output's plus 7 volts, all the other outputs plus 5, so those suitable for any kind of gating purpose. You can also use the reset input now with, say, another oscillator. So that's producing some really gnarly sounds. So that's pretty much a basic run through of what the DC1 can do. Again, just to finish off, I'll show you another one of my favourite patches, which is the DC1 controlling a filter. So if I use my mixer, to mix together some of the DC1 voltages and use that as a frequency CV, I can effectively use the DC1 as a CV sequencer. Let's go for a bit of an odd sequence length, let's say 6. Nice triple time stuff. So if I take a saw from the AFG, filter it down, get the CV going, slow that down a little bit. levels of the mixer are changing the steps. You might be able to hear some bleed from the clock input onto the outputs. I personally quite like this, but as you can tell, it may be annoying at times. To avoid this, I simply take that square, feed it into an envelope, and use the envelope's output. And set the envelope to a very, very, very short trigger output. I mean, I can barely see the LED there turning on. And it still clocks fine. So again, if I clock at audio frequencies, I can get some very strange, interesting sounds from modulating the filter. It's quite nice. So that's a basic rundown of what you can do with the DC1. I'll just carry on patching for a while and see if anything interesting comes out. And again, if I just totally ruin this patch by using the disable, let's change to the Doepfer VCF. Again, you can get some interesting kind of semi-random rhythmic effects by using different sources on those three inputs. So that's a basic run through of what the DC1 can do. Again, it's very, very open-ended. I've even had some ideas about using this as a kind of quadrature source. So filtering down the 4 outputs so they're almost kind of sine-like, and using those as quadrature sources, but I haven't actually done that yet. Again, I think that's going to be a very, very kind of precise patch. But I hope that makes things a little bit clearer about the DC1. I've had quite a few questions about why 10 steps, and you know, how does this power up? It's a Eurorack module. It's designed fully to use with the standard kind of array of you know, LFOs and envelopes out there as a triggering unit. Stuff like the sequencing came later. But yeah, as it's basically, you know, its main purpose as an event sequencer, it works great. And yeah, I hope to see more of them out there. That's great. Thank you for watching. Cheers.